to the Math Happy Hour. And today we're talking about WebAssign and problem solving strategies. So let me get started. Just for all of our students, if you guys have not yet logging into your WebAssign Engage, this is how you could log in. This is the website. In fact, if you just type webassign.net, it should take you directly into the WebAssign page. And often your instructor will give you a class key so that you can register in the course. So as you can see on the image in the circle, it says where you would enter your class key so that you can register for your class. Sometimes your WebAssign Engage account is already integrated in Blackboard, and all you need to do is click one of the assignments on WebAssign and it will take you on Blackboard and it will take you directly into WebAssign. So we always recommend that you follow the instructions that your instructor give you as they may change. Once you have done the initial login, you could log in directly to WebAssign if you prefer, but that first time that you log in, you want to follow the instructions in your syllabus, or if they're not in the syllabus, whatever your instructor recommended that you do. As mentioned, typically the class key, if your instructor give you a class key, the class key would start by saying EPCC, and they would be a sequence of numbers that you need to enter. So that's what the example is showing you. And as mentioned, if not needed, then all you might need to do is click one of the homework assignments on your Blackboard, and that should direct you into WebAssign. So once you have logged in, this is how your Cengage dashboard, that's how your Cengage account looks like. And so you can check all of your courses that have Cengage. So if you're using Cengage for English, psychology, or any of your other classes, you should be able to see them on the tab that says courses. So this is kind of like your entry point when you log in into Cengage, in your Cengage account. Most of our students already pay for the access for the textbook on their tuition. So do not worry where it says review purchase. You probably do not have to buy anything. If it requests you to buy something, I recommend that before you do it, you ask your instructor. Like, hey, it's telling me that I need to pay for something. Most of the time, your instructor will tell you that it's already been paid for, so you don't have to worry. That's what we call the first day access. So if you have first day access, you already purchased all of that, so do not worry about anything else. You can also go in the top of the left menu. You'll see a drop-down arrow, and you can go and change your password if you prefer to have a different password, or add another email in case you want to recover your account later. So those are good things that you can do. As mentioned, all of your WebAssign courses should be listed in courses. So if you're taking more than one class, you can change from one class to another if you go to courses. And notice that on the menu, there's something called the rental option. And this is something that I always tell all of my students. If you want to get a hard copy of the textbook, everybody has access to an online version of the book. But if you actually want to have an actual textbook, which I'm going to be honest, I do. I prefer to have the hard copy, which may be beneficial. For example, if your internet is on and off and you're struggling like logging into the textbook, then it might be easier just to have a hard copy. So if that's something that you want, it is already included with your account. It is a rental, so you pay only for shipping. And at the end of the semester, you need to return it. So you're not really buying the book. And since it is a rental, it's probably much cheaper, probably like, I'm assuming between $15, $20, which would be like just for shipping. The next thing is, once you are in your Cengage WebAssign, and this is more specifically for math, if you're taking math 1332, then your actually WebAssign account looks like this. And notice that you can change it to Spanish if you prefer. So where the little globe is, then it allows you to change it. And I think I have a picture of how it looks. So once you change it to Spanish, everything, all of the options will be like all of the menus, all of the titles will be in Spanish. Everything will be in Spanish if you prefer to do that. Also, there's a little letter which is kind of like your mail in Cengage. So it's a good thing to check this frequently, because if there's any changes on the due dates of the homework, any messages that your instructor wants to send you, they'll probably email you through Cengage WebAssign, and you'll see them there. So if there's anything there, if you see that you receive like a little notification that you received an email, click on it, check. You'll have notifications of due dates, announcements, extensions, private messages from the instructor. Or if you sent a question, that you would receive the reply in there. And that's what my next slide is going to show you. Well, not the next one. Eventually, I'll show you where it says like ask your teacher, ask your instructor, and you receive the reply on that little envelope. Notice on the top you have all of the labels to navigate in WebAssign, which would be your entry point, which is home. Right now I'm at the very far right, which is my ebooks. So all of your ebooks would be listed here. And other my assignments. So if you want to look at the homework, all of the homework assignments, you can click on my assignments and it should list all of your assignments in there. Sometimes it only shows you the current assignments, but if you click on past assignments, it'll show you all of them so that you can take a look at all of them. Grades, there's also a grade option to check your grade on WebAssign. This is a very specific one for each class. Some instructors will have all of your grades on WebAssign, and they will tell you like, do not even look at Blackboard, your grade is completely on WebAssign. So just keep an eye for that, whether your instructor has all of your grades on WebAssign or all of them are in Blackboard. Communication, you could also receive you could also look at all of your emails if you click on communication. And you can send messages, you can send emails through WebAssign to your instructor by clicking on communication. So this is a picture of how the homework looks like. Notice that it's showing me the assignments that I have to do for this week. They're due on Sunday. Also, if you take a look at the little images that appear on the bottom, so this is a graded lab quiz. So this quiz, the image of a screen, this means, and there's a lock inside, this means that this assignment requires lockdown browser. So you need to download the lockdown browser for WebAssign before you can open the assignment. I'm sure your instructor will probably have instructions letting you know that you need to open the lockdown browser and then open the quiz, because that's the only way that it would open. The next screen actually shows you the password protected. So that means you need a special password to do this assignment. This also would be on the instruction from your instructor. Most of the time, maybe it's possible that your instructor doesn't want to start the assignment until a specific date. So you will get the password only until that date. And then the next image, there's a little clock. So this clock actually is telling you that this is a time assignment. So it's a clock that is timing how much time you spent on the assignment. And probably, especially for quizzes and exams, you may have 2 hours to complete it, or 3 hours to complete it, or maybe less. This depends on each instructor. Each one will set a different time. So Let me go into the next screen. Well, there's one more thing which it says you must achieve the percentage listed below on this assignment to access the assignment indicated. So especially with some, in some courses, whenever you have, and it may something that your instructor might decide anyway, that before you can take a quiz, like for example, in this image, you can see what it says practice quiz and graded lab quiz. So before you can actually open the graded lab quiz, which is the one that counts for your assignment, you have to complete the practice. Think about this as a review. And not only that, but you need to have a specific percentage. So once you pass the practice quiz with, let's say, an 80% or 70%, then you are able to take the actual quiz. This is obviously only to make sure that you're ready, that you don't just take the quiz and maybe you don't do well. So there might be some restrictions in there that only until you get a specific grade, you can open the actual quiz. Okay, and this is how the actual assignment looks like in WebAssign. So on the top, you have your score for each question. You could also see the total. Notice that in this assignment, in these questions, it doesn't show all of them. You gotta scroll down on the bar to the right to show all of the questions, but it tells you the points that each question may have. Notice that on the right, it shows you the due date again, and you can also see where it says request an extension. Most of the assignments in WebAssign, if you want to have an extension, it's easier if you just click on that link, because often students would send me a separate email requesting an extension, and what I prefer students do is that they use this button that says request an extension. So once you click on it, it'll ask you to enter a future date. I always recommend that students do not request more than a week, because that would probably make you fall behind. So I usually do not approve more than a week. So maybe 2 extra days, 3 days, 5 days, it is a good thing to request. And you also have the option to provide a reason. Please make sure that you provide a reason, just so we know why do you need the extension. Also, most of the assignments, they show my notes where you can take notes about each question. So in case you go back and review the assignment, you left in there some comments so that you don't have to be doing the question over and over again. Maybe by leaving a note, you can, it'll help you remember the entire solution. You also have the button, which is Ask Your Teacher. Sometimes this is disabled, so this will depend on your instructor. So if you see it, that means that your instructor is okay with you sending questions directly through WebAssign, which is very convenient, because when students ask me like, hey, I struggle on the homework, this problem was not clear, and of course I'm reading the email and I'm not quite sure what problem or which one of the assignments that is. So it's a good idea to use this button if you have it, because that tells me exactly the question and the assignment, so I know exactly what you're talking about. And often you will see the practice another version of the question. This is a great thing, so that before you do the actual, it allows you to practice before you submit your actual answer. Sometimes this is only enabled after you have after the due date, so that you can go back. If you're studying for a quiz or you're studying for an exam, you can go back and practice another question. If it is disabled, please make sure to contact your instructor. You might want to ask your instructor why that it says that it's not enabled, and they might enable it so that you can use it while you're doing assignments. And last, this is kind of like a typical question on WebAssign. It says, find the midpoint on the line segment. Notice that the parentheses are already included. You gotta enter the answer as a coordinate point. So all you need to do is type your number for X, separate with a comma, and then your number for Y. There's also the option for read it or watch it. read it will take you to the book exactly on the section where the midpoint is explained. So I recommend that you use that. And even better, watch it. These are really good videos and they're very short videos. So often I make a lot of instructors, we make our own videos, but I'm gonna be honest, when I make videos, my videos are usually like an hour long or 50 minutes. Even when I plan, like I'm gonna do it only 30 minutes, it ends up extending because I want to explain all of the details and everything. But these videos are like 5 minutes and they're specifically, it's an example that has the same text, it's just different numbers. So it's the same problem, just different numbers. So very, very useful. Not all questions have the watch it. I know students always ask me like, why? Because it is a video. So they always ask me like, why not all questions have videos? And this is from Cengage. We don't have the option to create a video in Cengage for each of the questions. So this is already from the book. So just keep that in mind. Some questions will have a video and not all of them. Okay. All right. So that was just a brief introduction to Cengage WebAssign. The title of the talk of this day was problem solving strategies. So we're going to talk about problem solving strategies. This is what you probably already covered in your class. So this is a review. And that's the purpose of this video. So starting with inductive reasoning. So inductive reasoning, it's when you get to a conclusion by looking at a specific examples. So you have examples, by analyzing these examples, you create a conclusion, kind of like a hypothesis. And then deductive reasoning is when you have more general procedure. So if you have a procedure and you're proving something that it's not only for this example, but it's for all of the examples, sometimes we call that a proof. So when you prove something using general assumptions that applies to all of the examples, that is called a deductive reasoning. So just this diagram, it's supposed to kind of like remind you. So the idea is inductive is when you go from specific examples to general, so a general conclusion of all examples. And deductive reasoning is you're proving everything in general and it applies to all the specific examples. Let's take a look at a more specifics. So for example, you could use arguments that could be inductive or deductive. An argument is usually like a sentence. It's something that is trying to convince you of a result. So number one says, the last major was honest. And then the current major is honest. So the conclusion would be all majors are honest. So this is an inductive reasoning because you are making the last sentence is the conclusion. You're making a conclusion based on the fact that the last and the current majors are honest. So you're concluding that all of them must be honest. And example 2 says, every word has the letter E in it. Therefore, your name has the letter E in it. And this would be a more deductive. So regardless, and now just think about like, these may not be necessarily true, of course, but the argument uses a deductive reasoning because it's going from a general statement that all words have the letter E to conclude that your name has the letter E. So it's just an example of how deductive arguments work. Okay, so this is precisely what I was mentioning. The first is inductive, the second one is deductive. A more specific problem, it says use inductive reasoning to predict the next number in each of the following lists. So for A, notice that if you analyze the numbers on A, the list of numbers that appear on A, it starts with 3, and then the next one is 6, The next one is 9, 12, 15. So the pattern you can conclude by looking at these specific numbers, at these specific examples, you can conclude that there's a difference of 3. So the next one is found by adding 3. And so if you want to predict what is the next one, so it ends at 15. But if somebody were to ask you, like, what would be the next number that appears on the list? Well, according to the pattern, that would be 15 plus 3, which is 18. So inductive reasoning is used here to find the next one. And for B, we could also kind of like look at the difference. So starting from 1 to 3, 3 to 6, 6 to 10, 10 to 15, well, notice that this time it's not constant. So on A, you're always adding 3. But there's still a pattern. So even though it's not always 3, notice that from 1 to 3, you actually have a difference of 2. From 3 to 6, you have a difference of 3. From 6 to 10, you have a difference of 4. So you're adding one more than the previous one. So to get from 10 to 15, you add 5. And this means that if you wanted to find the next one, the next number on the list, then you need to add now 6. So 15 plus 6, that would be 21. And again, this is an example of inductive reasoning because you're identifying a pattern by looking at the numbers already given. By looking at those specific numbers, you realize like, oh, they're adding one more every time. So now we're gonna complete the following procedure for several different numbers. And so the procedure reads, pick a number. So I remember, I always tell my students, back when I was a child, they would show this as a magic trick on TV. I remember even David Copperfield, that this was something that they would tell you like, hey, everybody at home, follow the procedure. And at the end, I'm gonna tell you what your number is. So it was sold as a magic trick. And it's pretty simple. So you could do it right now. You pick a number, it could be any number, it doesn't matter which one. Multiply the number by 8. Once you get a result, then you add 6 to the product. The product is the result that you got by multiplying. Then divide by 2, and at the end, subtract 3. And so following this procedure, you're supposed to get I'm supposed to guess what's gonna be the answer. So for example, if the number is 5, you multiply it by 8, so you get 40. Then you add 6, it becomes 46. Divide by 2, half of 46 is 23. And subtract 3, and your final answer is 20. And as it turns out, the answer is always 20. That's why it was sold as a magic trick, because then the magician would reveal at the end, like, oh, your number is 20. And you'd be like, wow, how did you know, huh? Well, why does it work? Well, picking an actual number, this example where I started with 5, is a specific example because I took one number and it gave me the 20. So this would be an argument, an inductive reasoning, and it only works for 5. Because if you chose a different number, then you have to again do all of the process so that you can show me that it also ends up in 20. So the best thing to prove this type of statements is actually by using deductive reasoning. So this is another example with 20. So it says multiply by 8, which is 10 times 8, which is 80. Add 6, which is 86. Divide by 2, half of 86 is 43, and subtract 3, which gives you 40. So my guess here, by looking at these two examples, is that your final number is always 4 times the original, because if you multiply 5 times 4, that's 20, and 10 times 4, that's 40. But if I wanted to prove these, I would need a deductive argument. So let's take a look at the next one. Here's another one with 7, another example. Same procedure, and at the end is 28. Well, we can see that my theory, my hypothesis seems correct. Huh? If you multiply 7 by 4, that will give you kind of like your final answer, which is 28. So if I was doing this magic trick, I would kind of like be able to predict what are you getting at the end. However, if I'm trying to convince that it is always the case that their result is going to be 4 times the original, I need to use a more general argument. So let's take a look what that argument would look like. Notice that this sentence, it says the final number is 4 times the original. Is this example inductive or deductive reasoning? Well, each of these are inductive because I'm only doing the whole conclusion, like the way that I made my hypothesis. I created a hypothesis by looking at specific examples, 5, 10, and 7, and it seems that at the end, I always get the original multiplied by 4. It says, if your original number is 12, what would be your final answer? Well, if my hypothesis is correct, I would multiply 12 times 4, and that would give me 48. So that would be my answer. Now, if you want to make a proof where it's a deductive, so you don't want to be doing example by example, but you can actually create a procedure to solve it for all numbers. It doesn't matter what number you pick. Then usually you start by selecting a letter. This letter represents the number that you pick. It doesn't matter what letter it is. In this example, the original number is represented with the letter N. You know that typically when you do equations in math, the typical letter is X. So if you want to change it to X, that would be fine. And multiply by 8. Well, multiplication by 8, if N is my number, that would be 8 times N, which in algebra, when you multiply a number and a variable, you just put them together side by side. So my result is 8N. Add 6. So this would be the previous result. You're adding 6, which is 8N plus 6. Divide by 2. When you divide 8N plus 6, anytime that you have multiple terms, because you have the 8 and the 6, you actually got to divide 2. You got to divide both of them or all of them if you have more. So since there is 2 terms, you got to divide A by 2, which is 4N. You don't do anything to the N. And you also divide the 6. It's not enough to divide the A. You got to divide both. So dividing the previous result by 2 will give you 4N plus 3. Finally, when you subtract 3, this is 4N plus 3 minus 3, which will give you 4N at the end. Because the positive 3 and the negative 3 cancel, so you get the 4N. And so notice that from beginning to end, if you started with an N and your final result is 4N, this means that indeed, anytime when you start with any number, at the end, you're going to get 4 times the original, which is 4N. So this is a procedure that uses deductive reasoning because it's not using a specific examples. It's not like I'm picking a specific number like 5 or 10 or 7. This is a proof that it's good for all numbers regardless of whichever number you started with. Okay, so let me move on to the next question. So in this course, you're gonna see a variety of questions, and one of the topics of the class is logic. And so we're gonna solve a puzzle by using logic. It says Brianna, Ryan, Tyler, and Ashley were recently elected as new class officers. President, Vice President, Secretary, and Treasurer of the sophomore class at Summit College. From the following clues, determine which position each holds. So we have these 4 students that were selected, but we don't know what role they play. So we gotta look at the clues, at these 3 statements to determine who's the president, who's the vice president, who's the secretary, and who's the treasurer. So number 1, it says Ashley is younger than the president, but older than the treasurer. And then number 2, Brian and the secretary are both the same age. And they are the youngest members of the group. And last, it says Tyler and the secretary are next door neighbors. And so in these type of problems, it is always a good idea to create a table. In math, we always recommend, and this is actually, if it was not mentioned in your class, it's on our book. So when you go and log in into Cengage and you read the textbook, this is one of the strategies recommended by George Polya. And this was a mathematician that had so many, after observing all of their students, he created like guidelines to solve problems in mathematics that always helps the students. And one of the observations that he did, and we always say in class, if it's possible, create a diagram, create a picture. Sometimes when we say a picture, it seems too generic, but more specifically, if you create a table to organize all of that information, makes it easier. So we have our table and we go sentence by sentence. So it says, Ashley is younger than the president, but older than the treasurer. So that means that Ashley cannot be the president and she cannot be the treasurer. Because if she was, then why would you say that she's younger than the president, right? She would be the president. So Ashley cannot be the president and she cannot be the treasurer. So you cross out those spaces. The next sentence says, Brianna and the secretary are both the same age. So again, Brianna is not the secretary. And they are the youngest members of the group. So this is to be taken into account for later. The last sentence, it says Tyler and the secretary are the next door neighbors. So again, that means that Tyler is not the secretary. So now you want to go back and read the whole information. So we already have, let's see what we can deduce from what we have. So the role of secretary can only be Ryan and Ashley. But we were told that Brianna and the secretary are the youngest members of the group. Ashley's older than the treasurer, therefore can be the secretary. So that actually excludes Ashley from being the secretary, which means the only possible that can be the secretary is Ryan. And so we put it in there. And so, of course, if we have 4 students and each one of them has to have one role, so you can cross out all of the other possibilities. Ryan is the secretary, so he's not the president, he's not the vice president, and he's not the treasurer. But that also cross out the possibilities for Ashley. So we deduct that Ashley, because it had said before that Ashley was older than the treasurer. And so this closed out the possibility for Ashley. So that means Ashley has to be the vice president. And it says that Brianna, so going back to the second statement, is the youngest, but Ashley is younger than the president, therefore Brianna can be the president. So this last statement can be used to deduce that Brianna has to be the treasurer, and therefore Tyler is going to be the president. So this is always a good strategy. There's a lot of these questions, questions in the section of like logic puzzles. And usually like by setting a table, checking possibilities, or if you make any mistake, it's fine, just go back and change it. But this is a great way to solve all of these questions by creating a table. And it can be used also in other questions, but mostly whenever you have like these type of puzzles, always creating a table, it's the most efficient way to find the answer. In section 1.2, we study about problem solving with patterns. And this is pretty similar to what we did before. When we were looking like, what is the next number on the list if you look at the pattern? Well, this list of numbers is usually called a sequence. And we consider it to be an ordered list. So we could say the first number is 5, the second number is 14, the third one is 27. So we assign a place and also the actual number. Like if I were to ask you, what is the fourth number on the list? Well, you start on 5, which is 1, 2, like first, second, third, fourth. So the fourth one is 44. Each of these ones is called the terms of the sequence. So if you want to find the next number, you could ask like, what is the next term on the sequence? What's the next term in the sequence? And let's see. So the dots at the end, the 3 dots, they're supposed to indicate that the list continues. So you should be able to find the next term and the following one and the following one. So this list of numbers, they're usually infinite. So you're trying to predict what is the next number on the list. It says, indicate that the sequence continues beyond 65, which is the last written term. It is customary to use the subscript notation and to designate the nth term of a sequence. So when we ask like, what is the nth term of a sequence? We're asking for the formula that generates any number. So again, we have an example. Here is a sequence. What is the next term? So this sequence has first, second, third, fourth, and fifth. So we're looking for the sixth one. What is the immediate one? So after 14, what would be the next one? Well, something that is very efficient is to create the differences. So often we're trying to predict like, hey, what do we need to add to the next one? And sometimes you will realize right away, like in this example. But if you don't see a pattern, just subtract the numbers. For example, we have the sequence and then we have 2, 5, 8, 11, 14. And if you subtract 5 minus 2, that gives you 3. 8 minus 5, that's 3. 11 minus 8, that's 3. 14 minus 11, that's 3. And so what we hope is that by looking at the differences, we can see the pattern. So this second line on the bottom is called the first difference. And sometimes as soon as you do the difference, you can already see the answer. Like in this example, because it's always 3, we can predict what the next number would be. So since there's a difference of 3, you can find the next one by adding 14 plus 3, which would be 17, which is the next term on the sequence. Another example, we have a sequence. Again, it has 5 terms, and we're trying to find the next one. Make sure to always read the instructions. And when you do the first difference, so you subtract all of the numbers, 14 minus 5, that's 9, 27 minus 14, that is 13, and so on. So you do the first differences, which means you subtract the difference between consecutive numbers. Well, maybe it might not be obvious right away what the pattern is. So the question is, what is the difference between this difference table and the previous one? Well, in the previous one, we had the same number all the time. It was 3. Remember that it was constant. You always got 3, 3, 3. But this one is not. So What you could do in these cases to find the pattern is you go one more time. So you see 9, 13, 17, and 21, you do the difference again. And so this second row of numbers is called the second differences. And notice that 21 minus 17, that's 4. 17 minus 13, 4 again. 13 minus 9, 4. So you can see that the second difference is constant. And now you work backwards, kind of like in the logic puzzle. You start by filling some of the information, you find a pattern, and now you can start working backwards. So the difference between the second difference and the first, if I wanted to find the next immediate number, then since the difference is 4, I would need to add 21 plus 4, and that would give me the next value, which is 25. So 21 plus 4 is 25. And to find the next term on the original sequence, all you need to do is 65 plus 25, or in whichever order, 25 plus 65, and that gives you 90, which is the answer to this question. So when you have a sequence, very often you look at the first difference, and sometimes you will find a pattern, and if you don't, it's okay. The recommendation is go one more. Apply the difference one more time, the second difference. You'll find a pattern, and then you can find your answer by working backwards. So you start by finding the middle number, which is 25, and then you find the top number, which is 90. So let's see if we can use a difference table to predict the next term. So I start by doing the first differences by subtracting all of these consecutive numbers, and I get 89, 59, 35, 17, 5. Again, I don't see, it's not the same number always, so the recommendation is let's do it one more time. So subtract the next numbers, which is 89 minus 59, that's 30, and then 59 minus 35, that's 24, 18, and 12. Now, I did not get exactly the same one, but I could probably find a pattern. But if you don't find a pattern, if you don't know what's the relationship between 12, 18, and 24, and 30, then you could do a difference one more. And so this one is in pink, and it's pretty small, but the difference is 6. So between 12 and 18, there's a difference of 6. Between 18 and 24, there's a difference of 6. Between 24 and 30, there's a difference of 6. So if you do the differences a third time, you'll see the pattern. So that's kind of like this procedure of finding the difference is just continue finding the differences until you find the pattern. So in this example, if you go to the third one, then you can see that there's a 6 difference. And now you work backwards. So to find the answer, starting with 30, you add 6. This will give you 36. And then go to 89 and you add 36, and this become 125. And finally, since the last term on the sequence was 207, so 207 plus 125 will give you 332, which is basically the next term on the sequence, like the final answer of this question. So finding the differences is kind of like a common procedure whenever you have sequences. So in this example, we have to do the first differences, the second difference, and even the third difference to get an answer. Section 1.3, it says, this is actually talking exactly about George Polya. And like I mentioned, he was a mathematician from Hungary that moved into the United States in 1940, and he created steps to help us solve mathematical problems. So the four-step problem-solving strategy that he recommends is: number one, understand the problem. This is in all mathematics, in all the time in mathematics. Make sure that you understand the problem. I often see students that they look at a problem and right away they want to start doing multiplication, division. Make sure that you read it. Make sure that you understand what is it asking first before you do anything. Like, think about, like, what is it asking me to do? Like, what is it expecting as the final answer? Number two, devise a plan. So this is like, once you know what you're looking for, this is where you gotta like think: should I multiply? Should I add? And at this point, it's a good idea to carry out the plan. So often in mathematics, we don't find the answer immediately. And many times the students, they based the success of solving mathematical problems if you can solve it right away. But this does not happen in mathematics all the time. Often you gotta like try it, see if that works, and then you try something else. So when you carry out the plan, you can try different options and see which one makes more sense. Last, review the solution. This is kind of like similar to checking the solution. So once you have an answer, go back and read the question and see if your answer fits the problem, if it makes sense. Often, if it's a question that gives you numbers, you can compare your answer to those numbers and kind of like think about it like, does my answer make sense? Was I supposed to get a positive number? Was I supposed to get a smaller number? And so on. So let's take a look at another problem. It says the number of ducks and pigs in a field totals 35. The total number of legs among them is 98. Assuming each duck has exactly 2 legs and each pig has 4 legs, determine how many ducks and how many pigs are in the field. So following the strategy is, we read the question and make sure that we understand it. So we have 2 types of animals, ducks and pigs, and in total, it's supposed to be 35. And we know the total number of legs is 98. So how can we use that information to determine how many pigs and how many ducks are there in total? Well, a good way, like we said, is draw a picture. Creating a diagram or a picture will help. So you can represent the picture where you have all of the 35 animals, and then you could put some legs in there. So for example, I put 2 legs on each one of them, and then I counted. Since it's 35, if you multiply by 2, that would be 70. So if you count all of the legs, this is 70 legs. But notice that we have a total of 98 legs. So we're missing some legs. Well, what we could do, a simple way of solving this question would be, well, why don't I add 2 more legs? So since pigs have 4 legs, those ones that have those extra legs are gonna be the pigs. And so we can do that until we find all of the pigs. Now we could go and do the math. So this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the first row is actually 14. This would be my pigs because each one of them has 4 legs. And so if I count, this is adding 14 times 2, which is 28. And if I do the math, like 70 plus 28, that gives me the total 98. So this combination, by making all of the animals on the top row, on the first row, 4-legged, gives me the total amount of legs, and it also gives me that these are my pigs, and then everything that is below are gonna be ducks. And so the final answer is that I have 14 pigs, which is all of the circles on the first list, and then 21 ducks, which is all of the circles from the second row below. Another way of solving this question is by creating a system of equations. So you can count, if you want to find the number of ducks and pigs, you could set up an equation. D represents ducks, P represents pigs. So if you added D plus P, that has to give me the total of animals, which is 35. And then since each duck has 2 legs, then you multiply 2 times D, so that's the number of legs for the ducks. Since each pig has 4 legs, you multiply 4 times P. And if you add the legs, the total has to be 98. So we have a system of equations, and if you find D and P that solve this equation, that would be your answer. Well, to solve the system of equations, you can use algebra. That's if you know how to solve equations. There's different ways. One way could be substitution. In this example, I use elimination. So to eliminate the D variable, I notice that below I have 2D. So I multiply the first equation by 2. So I get 2D, 2P, and 70. And not just by 2, I'm going to multiply it by -2 because I want to cancel them. I want to have a -2 and a +2. Because if you add -2 plus 2, it gives you 0, which means it cancels that variable. So when I add these equations, -2 and +2 cancels with the D. So in algebra, you can only add like terms. So the ones that have the same letter have to be added with the same letter. So the D for the ducks cancel, and the P's, -2P plus 4P, will give you -2 plus 4 is +2, and -70 plus 98 is 28. And you get the equation 2P equals 28, divide by 2, and this becomes P equals 14. So by using algebra, it also gives me the same answer that the pigs are 14. And then I could go back and use my initial equation and substitute 14 and solve for P. And I get the same answer. 35 minus 14 is 21, which is the number of ducks. Another type of questions that we study on this section is identifying what is the last digit when you raise a number to a power. So in this question, it says John needs to figure out what the last digit of which is the ones place of the number 4 to the power 200 is. He is willing to give the first person who can tell him his number a prize. What is the last digit of the number 4 to the power 200? And so when you read this question, it's like, what is the last the digit of the ones? Notice that, remember that when you do powers, the numbers usually get bigger. Like if you do 4, let me see if I have some examples here. So a good strategy is to start by looking at the small cases. To start by looking at the specific examples. So this is inductive reasoning. So the first power, 4 to the power 1, is just 4. And then 4 squared, this is 16. 4 to the power 3, this is 64. 4 to the power 4, this is 216. 4 to the power 5, this is 124. You could do this with a calculator or simply by multiplying the 4 as many times as the exponent. And once you have a few examples, then you look for a pattern. If we take a look at the numbers, I have 4, and because it's only one digit, then the last digit is 4. If I look at 4 squared, the last digit is 6. So the last digit is the one, the digit on the place of the units or the ones. Sometimes it's called the place of the ones. And so, and then the next one, 4 to the power 3, is actually 4. 4 to the power 4, the last digit is 6. 4 to the power 5, the last digit is 4. So by doing this, these examples, we can see the pattern, huh? It alternates between 4 and 6. 4 and 6. 4. So the next one, if I were to do 4 to the power 6, the digit, the answer would be 6. So can we predict what would be the last digit when we have 4 to the power 200? Well, the last observation that we need to make is that anytime that the exponent is an odd number, we get a 4. And if the exponent it's an even number, you get a 6. So notice that all of my odd numbers, like 4 to the power 4, 4 to the power 3, 4 to the power 5, the last digit is 4. And all of the evens, the last digit is 6. So that's our hypothesis. So to answer this question, since the exponent 200 is an even number, then the answer should be that the last digit is going to match the evens, which is 6. Okay, so I realize I've come to the end of this time, so I'm going to stop here. I'm going to give back um, the microphone to the host. And
Thank you, Mr. Tintos. I appreciate you. Just real quick, everybody, I'd like to point out that you can download this presentation today. If you go up to the top right corner, there is a box with an arrow pointing down. If you click it, you can download this presentation while it's on the screen. I'd like to take a moment to thank you all for coming today and spending your Friday with us. I'd like to thank Mr. Tentos for presenting for us on these wonderful topics. And I'd like to take a moment to mention a few items that we do have in the chat. We have our survey for Tohono virtual events. If you have an idea for a great survey or would like to give us suggestions for improvement, please click that link and give us your feedback. We also have a link to the YouTube playlist for these videos that we make. It's on the EPCC YouTube channel. That link is also in the chat, but if you don't have the link, you can go to YouTube, type in Tohono Virtual Events Playlist, and it'll pop up for you. Now, I'd also like to invite you to the sessions for next week. Let me go ahead and put that on the screen. On the screen, I have for January 30th is our next session for a Happy Math Hour for Math 1332. We will be going over set theory, basic properties of sets, complements, subsets, and Venn diagrams. For Math 2412, trigonometric graphs. And then our 1 p.m. session will be student success topics. We'll be covering drug dosage workshop with the RG tutoring team. For today, January 23rd at 1 p.m., we'll be having for student success topics, we'll be going over student success tutoring and Tohono passports. Thank you all for coming in today, and we hope you have a lovely weekend.